Hi children, good morning everyone. Welcome to math class. How was your online exam? All exams were easy? I think everyone will be well attended. Anyway, your marks will be sent soon. Okay, in the last two classes, we have discussed two methods of finding square root of numbers. That is prime factorization method and long division method. Isn't it? I hope everyone understands these two methods. If anyone still does not understand these two methods, ask in the online class. I will clear it. Okay. So, one more topic is left in this chapter. That is finding square root of decimals. Yes, today we are going to find the square root of a decimal number. Here we are following the same method. We proceed in a similar manner. But the only difference is that there is a decimal point in the number. Okay, let us see how to find the square root of a decimal number. Okay, first example 17.64. The first decimal number is 17.64. So a decimal number has two parts. This is the whole number part 17 and this is the integral part or decimal part, that is 6 and 4. Okay. So let's start the long division. As we all know the steps. Here we are following the same steps. So what is the first step? Yes. First, write the number in the division format. So this is the division format. Just draw the division format. And write the number inside that format. That is the first step. Now, next step. Yes. Put a bar. Place a bar over every pair of digits. Starting from the unit place. Starting from the last digits. Okay, just place a bar over the number. Every pair of number. So, first pair. From the last digits, these two are the first pair number. So, place a bar over that number. Again, count two numbers. So, this is the second pair. Again, put a bar over that number. Okay, that is the second step. Now, what is the third step? Yes, take the first dividend as 70. Then, find the nearest square number of this number. That is the first dividend. Find a nearest square number of the first dividend. Here our first dividend is 17. So the nearest square number before the 17 is, yes, we know that it is 16. 4 into 4 equal to 16 is the nearest square number. 4 into 4. Okay, 4 4s are 16. So what we do? Yes, we can write this 4 as divisor and quotient. 4 into 4 as divisor and quotient also. So write that divisor and quotient. So this is the divisor place. We know that. Here you can write the divisor 4 and quotient here above the number. So quotient here 4. Okay, then yes, 4 into 4 equal to 16. That product, that square number should write under the first dividend. So, write that 16 under this 17. Okay, then subtract. 17 minus 16 is 1. 1 is the remainder. Okay, then what is the next step in the long division method? Yes, next step is bring down the next bar number. But here we have a decimal point in the number. So, that decimal point shows this is the decimal part. 64 is the decimal part. So, we can put a decimal point into the quotient also. If the dividend has a decimal point, then we can put a decimal point in the quotient also. Okay, then bring the next bar number. Bring down the next digits, that is 64. No need to put that decimal point here. We place that decimal point here. Here you just bring down the digits only. So the number becomes 164 is our new dividend. Okay, then what is the next step? Yes, next step, add this divisor and quotient. Just find the sum of the divisor and quotient that we got. 4. So what is the sum? 4 plus 4 equal to 8. Write or enter that 8 just near to the new dividend. That 8. Okay, write that 8 here with a blank space on its right side. Enter that 8, sum of the divisor and quotient, just near to the new dividend with a blank space on its right side. Okay, yes. Then what is next? Yes, next you have to fill this blank with a possible digit. And their product should be less than or equal to the dividend. So, think the number which their product will be equal to or less than this number 164. Okay, if we put 1 in the blank space, we can multiply it with the 1 itself. So, 1 into 1, 81. If you put 1 in the blank space, we can multiply this number with the 1. So, 81 into 1 becomes 81. No change. Then, put the next number. Place the next digit. Yes, just put the digit 2. So, what is the product? If we put 2 in the blank space, then we can multiply it with the 2 itself. 2 and 2 as the divisor and quotient. Okay. So, 2 into 2, 4. Then 2 into 8. 2 8s are 16. So, what is this? 164 is our given dividend. So, if you put 2 here and multiply that with the 2, we will get the dividend as 164. So, these 2 and 2 are our divisor and quotient. So, place that divisor 2 here and quotient 2 here. Then write the product 164 under this number. Then as usual subtract 164 minus 164, 0. So we get a remainder 0. Okay, and no bars left. So no bar left. So the square root of this decimal number, that is 17.64. Square root of 17.64 equal to, what is it? It is not 42, it is 4.2. The square root of the number 17.64 is 4.2. Okay, clear? Yes. The same method, the same long division method. We followed the same method. Just to change that there is a decimal point in the number. So, we can put a decimal point in the quotient also. Clear? Okay. Now listen. One more interesting fact about square root of numbers. That is, without calculating or without finding the square root of numbers, we can say or we can find the number of digits in the square root of numbers. Without calculating the square root of the number, we can say the number of digits in the square root. That is, if a perfect square have 1 digit and 2 digits. If a perfect square number have 1 digit. 1 digit perfect squares. Which are the 1 digit perfect squares? 4. Then 9. That's only these two. 1 digit perfect square numbers are 4 and 9. Okay. Then, so in a 1 digit and 2 digit perfect square number, their square root will have only 1 digit. If a perfect square number having 1 digit and 2 digits, then their square root will have only 1 digit. Okay, let us check. 4 and 9, we know that 1 digit perfect square number. So their square root have only 1 digit, 2. 2 2s are 4. Okay. Then square root of 4 is 2. Square root of 9 is 3. 1 digit. Then 2 digit numbers. 2 digit perfect square numbers. Which are the 2 digit perfect squares? Yes. First one 60. Then 2 digit 4 4s are 60. 25. 5 5s are. Next 2 digit number 25. Then next 36. Then 49. Then next these are 2 digit perfect square numbers. Then what about their square roots? Does it have 2 digits? No. Their square root have only 1 digit. 49. Square root of 49. 7. Square root of 81. 9. Square root of 36. 6. Clear? So, if a perfect square have 1 digit and 2 digit, then their square root will have only 1 digit itself. Okay. Then what about if a perfect square have 3 digit and 4 digit? 3 digit and 4 digit. Then their square root will have 2 digits. If the perfect square have 3 digit and 4 digit, then their square root will have 2 digits only. Okay, like if a perfect square have 4 digit and 5 digit, or 5 digit and 6 digits, then their square root will have 3 digits only. Okay, let's check it. If there are n numbers, if a perfect square have n numbers, then if n is an even number, then their square root will have n by 2 digits. If n is an even number, that is 1764. This is an even number, 4 digit. 4 is an even number. So their square root will have n by 2. What is our n? 4 digit. 4 by 2 equal to. Clear? If a perfect square number have n numbers, that n is an even number, then their square root will have n by 2 digits. And if n is an even number, then their square root will have n plus 1 by 2 digits. Clear? Nothing, very simple. That is, if a perfect square having n digits numbers, n means any number. If it is 2, 3, like that. Okay, just a number. Just think, no, 225 is a perfect square number. We know that 225 is a perfect square number. How many digits are here? 3 digits. That is n equal to 3 is an odd number. So n equal to here odd number. If n is an odd number, the number of digits is an odd number, then their square root will have n plus 1 divided by 2 digits. Their square root will have n plus 1 divided by 2. That is, here n equal to 3. 1, 2, 3 digits. 3. So what is their square root will have 3 plus 1. 3 plus 1, 4. 4 divided by 2. 4 by 2 is 2 itself. That is, square root of this 3-digit number will have how many digits? 2 digits. That I told you. If a perfect square have 3 digit and 4 digit, then their square root will have 2 digits only. Okay. Then, if n is an even number, okay, just an even number. Okay, 1, 2, 2, 5. Okay, this is a perfect square number. Okay, just take this is a perfect square number, and here n equal to 1, 2, 3, 4, an even number, and so their square root will have n by 2 digits. N by 2, that is 4 by 2 equal to 2 digits itself. So, clear that? Is that clear? 3 digit and 4 digit, and their square root will have 2 digits. Then if it is a 5 digit and 6 digit, then their square root will have 3 digits. Okay, like 7 digits and 8 digit number, their square root will have 4 digits, and so on. A simple fact. Okay, if n is odd, n by 2 digits. It will have n by 2 digits. If n is an even number, then it will have n. If it is even, n by 2, and if n is odd, it is n plus 1 divided by 2. Okay, is that clear? Even, just n by 2. Odd, n plus 1 divided by 2. Okay, clear? Okay, now some more problems related to this square root. That is, in the previous topic, we did that type of problems. Which is the smallest number multiplied to get a perfect square? Like that. Okay, here we are subtracting and adding. Subtract and add numbers to get a perfect square. Okay, let's do one problem. Okay, I will read the problem. Listen. Find the least number that must be added to 1300. Here the number is 1300. Find the smallest number. That is least number. Find the least number that must be added to this number so as to get a perfect square. Also find the square root of the new perfect square number. The same model, but here we are adding or subtracting. Here we are adding. So what is the least number? Find the least number that must be added to this number. Get a perfect square number. Okay. Okay, let's do. The same way. For anyway, first we can find the square root. Okay, here we follow the division method, not prime factorization method. Okay, so as long division, find the square root. Okay, what is the first step? Place bars, first bar, second bar. Okay, first bar, second bar. Now, 13 is our first dividend. So, the nearest square number before 13 is 3 3s are 9. 4 4s are 16. That is not here. So, 3 into 3 equal to 9 is the nearest square number. So, write that 3 as divisor and 3 as quotient. Then, yes, write the product 9 under the first dividend. 13 by 9 equal to 4. Isn't it? Yes, remainder is 4. What is next? Yes, just bring down the next bar numbers, that is 0, 0. So our new dividend, our number becomes 400. What is next? Yes, find the sum. Just add these two numbers, add. Find the sum of divisor and quotient. That is 3 plus 3 equal to 6. Write that 6 near to 400 with a blank space. Just leave a place. Okay, a blank space for writing a divisor and a quotient. Okay, now place the numbers. So which is 1 not needed because 61 into 1 becomes 61. Now 2 become 124. Now 3, I think 3 3s are 9, 6 3s are 189. Then 4, what about 4? 4 4s are, okay, let's check. 6 with 4, 4 into 4, blank for 4. 4 4s are 16, 6 4s are 24 plus 1, 25. Okay, not nearest. Then, what about 6? 6 with 6. Okay, let's find. 6 6 are 36. Then balance 3. 6 6 are 36 plus 3, 39. 396. Is it near to 400? Yes. Okay. So, write that 6. Here, 6 and 6. 396. Now, subtract. Yes, 400 just minus 396, remainder 4 only. Is this the perfect square number? No, because we have a remainder 4. If the remainder is 0, that number is a perfect square. But here, the remainder is 4. Therefore, this 1300 is not a perfect square number. To make this number as a perfect square number, by adding what? That we have to find. Okay, so if we put 6 here, the number is 396. Okay, let's put next number. We want to make this 1300 a perfect square number. So we can add the numbers as many numbers. Okay, so just what will be the next perfect square number? If it is 7, that will be the next perfect square number. If we put 7, that will be the next perfect square number, isn't it? If we put 6, the perfect square is 396 and there is a balance remainder 4. And if we put 7, okay, what is the next perfect square? Let's check. 7. If you put 7, the next perfect square is 7 7s are 49 and balance 4. Then 6 7s are 42 plus 4. 42 plus 4. It is 46. So what's the number? 469. But we have only 400. So to make this 1300 a perfect square number, we need to add 69 plus 69 because we have just 400. If we add 69, we will get the next perfect square number, that is 7. Clear that? Is that clear? Here we have only 400, so it is not a perfect square. There is a balance. 4, remainder 4. If we add 69, then we will get the next perfect square number. That is 469. So what we need to add? Yes, we need to add just 69. 469 is the next perfect square number. If we put 7, we will get next perfect square as 469. And we have 400 also. So just add that 69. So that number is the next perfect square number. Okay, so no need to add this 69 here. We need to add that 69 here. We want to make this 1300 as a perfect square number. So we have to add 69 here. So what will be the next perfect square? If we add 69, it becomes 1300 plus 69. So this is the next perfect square number. Then what is the square root of this number? Is it 6? No. We add 69. So that means the next perfect square. So this 6 becomes 7. Okay. So the square root of this number is 37. Clear? Is that clear? Okay. So just think. Okay. Anyway, you just first find the square root using long division method. If we get a balance there, it is not a perfect square. In the prime factorization method, if a number does not have a pair, it is not a perfect square number. Like that, if we get a balance, if we have a balance, then the number is not a perfect square. So we make that number to be a perfect square number. We have to add numbers. So here you can think that number. Okay, if we put 6, the number is not a perfect square, we get a balance. So just put the next perfect square number, that is 7. If we put 7 there, the number becomes 496. So what we need to add it here? Yes, we have 400. Already we have 400. If we add this 69, if we add the 69 to this number, we will get the next perfect square number, that is 469. Then 7 becomes 490, 69, 0. Okay. So no need to add that number here. We need to change the first number, divided. Okay. So here you can add that number 69. So this is the least number added to get a perfect square. So this 1300 become a perfect square. That is 1369. And square root of that number is 37, not 36. We add here 69. So it becomes 37. Now it's clear? Okay. Anyway, we will discuss the same problems in the online class. Thank you. Have a nice day.